Vanakkam. Starting from now till the end of this video, each and every second is going to be converted as a valuable time for you because you are listening the video lesson presented you by Vidhyalakshmi Senior Secondary School for the foundation course in mathematics, and we are studying the topic called as Indices in version 2.0, and this is our third video module of this lesson. Okay. In each and every video module, usually we are solving 5 numerical problems in the topic of indices in this version also, in the second version also. Okay, by the same way, in this video module, third video module also, we are going to solve 5 numerical problems in the topic of indices. Okay, let us begin our class with our first question now. Yes, you can see the first question here over the screen. If m and n are whole numbers, it is mentioned that m and n are whole numbers such that m power n is equal to 121. An equation is given. Okay, first I want to take that m power n is equal to 121, and then what it is said, then the value of m minus 1 the whole power n plus 1. It is asked to find the value of m minus 1 the whole power of n plus 1. We have to find the value. Okay, its value we have to find. Unless you know the value of m and n, you cannot find the value. We should know the value of m and we should know the value of n for to find this expression. Okay. So for that, what I wanted to do, I want to simplify this expression, that is the equation, and I will be going for finding the value of m and n. See, this 121 we can write like 11 power 2. Am I right? Yes, 11 power 2. 11 square is 121. So m power n is equal to 11 square we can have. Now we can equate these two. Because of that we have, because of that these two exponents are equated, we can equate the bases. So m is equal to 11, and also we can equate the exponents so that n is equal to 2. So from this what we are getting, m is equal to 11 and n is equal to 2. Okay, these values we are going to use in this expression. Okay, so when you use that, what you will be having, the value of m is replaced by 11, so minus 1 the whole power n is replaced by 2, so 2 plus 1, which is equal to 11 minus 1, you know that 10 power 3, and 10 power 3 is nothing but 1000. Yes, 1000 is the answer for this question, and it is actually option D. D is the correct answer. Option D is the correct answer. Okay, now going to the second question. Yes, second question is a tricky question that you have to approach in a different way. Your mind should work with presence. Okay. See, I want to take the question carefully here. 1 divided by 1 plus a to the power of n minus m plus 1 divided by 1 plus a to the power of m minus n. Okay. This we have to simplify and we have to find the answer. I would like to tell you one thing here. I want to make you remember one thing, one formula. It is that a to the power of m by a to the power of n is equal to what you will be writing? You will be writing a to the power of m minus n. This is called as the quotient rule of exponent. Am I right? Yes. So, if the given fraction is in the form of a power m by a power n, then you will be writing it in the form of a power m minus m. By the same way, I am telling you in the reverse order, if we are having an exponent in the form a power of m minus n, then it can be written in the form of a power m by a power n. So that rule I am going to apply here. So when I apply that rule, what here you will be getting 1 divided by 1 plus, here a power n minus m we are having. So a power n divided by this negative exponent will come with the base as like a power m. Do you understand? Okay. Then plus 1 by 1 plus a to the power of m, and this minus n will be carried to denominator as a to the power of n. Now here we have to take the LCM for the denominator part. So for that I take 1 upon the LCM we are having is a power m. So when I take the LCM a power m, what we will be having? So this will be cross multiplied with 1. So a power m plus a power n you will be having. This whole denominator is upon 1 and then followed by 1 by, here also we have to take the LCM. When we take the LCM, you will be having a power n as the common LCM denominator, and then after multiplying here a power n plus a power m, that is a power m plus a power n we can write. A power n plus a power m, and a power m plus a power n are same because addition we can write it in any way because it is commutative. Yes. So after writing this step, this a power m will come to the numerator because it is going to become the reciprocal. So a power m by denominator a power m plus n, a power m plus a power n, and here also this a power n will come to numerator. So a power n the whole divided by a power m plus a power n. Here on adding these two, because of that we are having same common denominator. So a power m plus a power n, the common denominator we have taken. Here the numerator is a power m and there we are having a power n. So same factors on the numerator and denominator, we can make cancellation, and the solution that we are getting for this question is 1. 1 is the answer for this question. Now moving to the third question, you can see that the third question over the screen. Yes. First of all, I wanted to take the question without any mistake because this is a long expression. X power b by x power c the whole raised to b plus c minus a multiplied by, this dot is nothing but multiplication, it represents multiplication, okay. Then x power c by x power a the whole raised to c plus a minus b, okay. Then followed by in product with x power a by x power b the whole raised to a plus b minus c. Okay. After writing this carefully, we have to apply the rule of exponent. Okay. What rule of exponent? Here I have the idea to apply the quotient rule for exponent because this is in quotient having the same base x. The base is same x. So x to the power, when I apply the quotient rule, you will be having b minus c. The whole power b plus c minus a. And when I apply the quotient rule here, x power c minus a we will be having, and the whole raised to c plus a minus b, followed by x to the power a minus b you will be having, the whole raised to a plus b minus c. Do you follow? Good. Which is equal to, then next what the property you are remembering? What the rule you are remembering? Yes. It is the power of the exponent rule. Power of the exponent rule we are going to apply here. So when you apply that, what you will have, x to the power of b minus c multiplied by b plus c minus a. Am I right? These two powers will be multiplied. These two exponents will be multiplied. Okay? Good. Then it is better to have the brackets here because we should not leave that bracket. Yeah, bracket is very important. Followed by x to the power of c minus a into c plus a minus b. Then x to the power of a minus b into a plus b minus c. Okay, clear? So we applied that rule. Then in the next step, yes, now we have to carry this product carefully in the exponent. Okay, I will be telling you. See, here first I want to take this b minus c and I want to multiply with this b plus c, because this is in the form of a minus b into a plus b. So we can apply the formula a square minus b square. Okay. So when you apply that, what you will be getting? You will be getting x to the power of b square minus c square you will be getting. Okay. After this b square minus c square, what we have to do? We have to multiply this same b minus c along with this minus a. When you multiply with this two, what you will be having? You will be having like minus a times b minus c you will be having. Okay. That's fine. Then by the same way we have to do the product here. But I am telling you all these are having the same base x we are having. So, and these are all in product. Okay. So, what we can do? We can apply the product rule for exponent. When you apply the product rule for exponent, what you will be having? The powers has to be added. That is, the exponents has to be added. So, by the same way, in the same step, I am actually adding all the exponents all together. Okay. See. So, carry the multiplication here. So, c minus a into c plus a, c square minus a square. Then, when you multiply here, you are getting minus b times c minus a. And here, you will be having a square minus b square. That a square minus b square, afterwards you will be having minus c times a minus b. Okay. Yes. That's fine. So, all this lengthy expression is upon this, that is over this x. It is the exponent of this x. Okay. Then next step, we have to simplify this. Then in the next step, we have to simplify this. So, we are having x here. Let us see whether anything is, yes, here something we can make cancellation here. This plus b square, and here we are having minus b square. Here minus c square we are having, and here plus c square. Here minus a square we are having, and here we are having plus c square. Yes, square terms are all gone away. Then next, we have to move for the simplification here. See, I want to change the color. Yes. So, I want to multiply this. So, when I multiply here, you will be having minus ab, and then minus into minus, it will become plus ac, followed by here, when you multiply, you will be having minus bc, followed by plus ab. When you multiply here, you will be having ac, minus ac. Yes, it is minus AC. Minus AC, and finally you will have plus BC. Okay, it is nothing but I am just making the product here. So, I am just multiplying this A along with B and this minus A along with C. By the same way here, this minus B is multiplied with C and this minus B is multiplied with this minus A. And at last, this C is multiplied with A. And this C has been multiplied with this minus B, minus C with minus B. So, because of that multiplication, I got this expression. Okay. Okay. Then next step, you can see that this is minus AB, this is plus AB, this is plus AC, this is minus AC, this is minus BC, and this is plus BC. Cancelled. So, what is the remaining part we are having after cancelling everything? We are having just x to the power of 0. Yes, x to the power of 0. Definitely you know the reason why I put this one, if you are listening this video series continuously. Option B is the correct answer. Going to the fourth question, given that 10 to the power of 0.48 equal to x, then 10 to the power of 0.70 equal to y, and at last it is given x power z is equal to y square. Then the value of z is close to, it is asked to find the value of z, not to find the exact value, it is asked to find the value with which it is closer to. Okay. Okay. I want to take the given expression carefully. Okay. Let me take This 10 power 0.48 is equal to x, it is given, and then 10 power 0.70 is equal to y, the second expression, and at last we are having x power z is equal to y square. So x power z equal to y square. When you have the value of x and y, then only you can able to find the value of z, because in this expression only the term z is involved. Okay, if you want to find the value of z, definitely you need the value of x and y. Okay, that x value here it is given in the form of 10 power 0.48, and here the y value is given as 10 power 0.70. Yes, directly it is given, no need to do anything with this. We can directly substitute with that. Yes, we can directly substitute in that expression. But before that, I want to make this like x to the power of 10 power 0.48. I do not want to travel with the decimal. So I just convert this 0.48 as 48 by 100. And by the same way, this y value I am going to convert like 10 to the power of 70 by 100. Okay. Then I need to use these two values in that expression, third expression. When I use that, what I will be having? See, x value is 10 to the power of 48 by 100, the whole raised to z, because we are having x to the power of z, equal to y value we are having here 10 to the power of 70 by 100, the whole raised to 2. Okay, then you see 10 to the power of 48 by 100 z, you all know the reason, which is equal to 10 to the power of 140 by 100. Definitely you know the reason of converting this 70 into 140. Yes. Okay, then next you can see that, yeah, same base. Powers can be equated. Okay, when you equate the powers, what you will get? 48 by 100 z is equal to 140 by 100. 140 by 100. Okay, clear? Then we can make here these two hundreds to be cancelled, and the value of z is given by 140 divided by 48. 140 divided by 48. Yes, this in turn we may simplify 140 by 48. We can make cancellation with 2. So that you will be having 70 here, and here you will be having 24. Yes, furthermore it is again cancelable. So we can have 35, and here you will be having 12. So the final simplified one we are having is 35 by 12. 35 by 12 we are having. Okay. This 35 by 12. When you divide this 35 by 12, you will be having 12 threes are 36 actually. So definitely it is not going to be beyond 36. This is not going to be beyond 3. Okay, 12 threes are 36. So, but here we are having only 35. So the answer does not going to beyond 30. That is 3, beyond 3. It is not going to beyond 3. So it must be within 3 and nearest to 3. That is 2.9. The nearest value is 2.9. The nearest value of z is 2.9. So approximately, that is to the nearest, the value of z must be 2.9. 2.9. Understand? Yes. Then going to the last question of this session. This is somewhat simple question when compared with the previous one. Okay. I just take the question given here, 2 to the power of 73 minus 2 to the power of 72 minus 2 raised to 71. All are having the same base, thank God, is same as that of, so first let us simplify this, okay, afterwards we will come to a conclusion. How I am going to simplify? See, you have to understand the meaning. Here 2 we are having 73 times. Here we are having 2 72 times and here 71 times. So, in common, in general, we can take out 2 71 times from each of the terms. So, after taking 2 71 times from this, you will be having 2 times, because 71 plus 2 is 73. And here after taking out 2 71 times, you will be having only 2, because 71 times and here 1 time, 72 times. So, this whole 71 times comes out. So, what you will be having? 2 power 0. No 2, that is no any times of 2. Okay. So, which is equal to 2 to the power of 71, I just keep it, and 2 square is 4 minus 2 minus 2 power 0, you know, 1, which is equal to 2 to the power of 71, 4 minus 2, 2 minus 1, 1. 1 multiplied with this 2 power 71, 2 power 71. So, 2 power 71 is the answer for this question, and it is actually matching with option C. Yes, good. Successfully completed today's lesson by solving 5 numerical problems from the topic of indices. And as usual, I want to tell you that class notes and class assignment are available in the link given in description area. Please make use of that. Solve the assignments given to you, and it would be much helpful for you. Finally, I want to tell you, if you are interested with this video and if you are benefited with this video, please like the video and also share with your friends and give your valuable comments. Thank you all. God bless you all. See you in the next video. Bye-bye.